Hello class, and welcome to today's algebra lesson, which is about linear inequalities with two variables. By the end of today's lesson, you will be able to graph the solutions to linear inequalities. So linear inequalities with two variables is essentially taking slope-intercept form, so y equals mx plus b, and the equal sign is replaced with an inequality, so less than, greater than, less than or equal to, greater than or equal to. So instead of just having the line be the ordered pair solutions, the solutions are anything that are going to make the inequality true. So it may or may not include the line, and then it's going to include some shading on either side of the line. If the inequality has a greater than or equal to or less than or equal to, so if it includes the equal to part, you are going to be using what's called a closed boundary line. So when you graph, you'll graph normally with one solid line. Think of that when we were talking about singular inequalities as that filled in dot when you were graphing. The open boundary line is for less than or greater than, and that is going to be a dashed line. So still graphing a line, but instead of being solid, it's going to have dashed, and that is going to be our open circle. If it is a solid line, the line is included as part of the solution. If it is a dashed line, then it is not. So when we graph these inequalities, we're going to start graphing them just like you would have graphed in y equals mx plus b form. So we're going to pull out our y-intercept first, which in this case is 0, 4. And then we're also going to look at the slope, which in this case is up 2 and right 3. So we're going to put our point 0, 1, 2, 3, 4 onto our graph. And then we're going to go up 2 and over 3. And you can repeat that process again, up 2 and over 3. Now, because we have a greater than or equal to, we are going to use a filled in line or a solid line as we graph. So there is no dashed line here because we have our equal to included. The way this differs from y equals mx plus b is now you need to pick a test point to plug in to decide, are the answers to this inequality above the line or below the line? So I usually like to pick 0, 0. Honestly, you can pick any coordinate pair on the graph, but personally, I usually pick 0, 0. So what that means is when you plug in 0 for y and we plug in 0 for x, we need to decide if this is a true or false statement. So 0 is greater than or equal to 0 plus 4, giving me the statement that 0 is greater than 4. 0 is not greater than 4, which means that the point 0, 0 cannot be part of my answer. If 0, 0 can't be part of my answer, that means anything below the line is not going to work. So then what you are going to do is you're going to take and you're going to shade in the other side of this line. So you want to make sure you don't want to do what I just did, which was cross over the line. You want to make sure that you stay on the correct side of the line, getting as close to the line as you can. A little bit more difficult when I'm on the computer here, but make sure when you are shading that you are staying on the correct side of your line. So what that means is anything above this line, so this point right here at 1, 1, 2, 3, 4, 5, 6. 1, 6 would work for this equation. 0, 7 would work for this equation. Negative 10, positive 10 would be a solution to this equation. So every single ordered pair on this side of the line will satisfy this inequality. All the ordered pairs below the line are not answers to this inequality. Go ahead and try this one on your own. So first we pull out our coordinate pair, which is at 0, 5. Our slope is 1, 1, so up 1 and over 1. We have a solid line because we have that equal to part included. Then when I plug in 0, 0, or you could have picked any other test point, I end up with a statement that says 0 is greater than 5, or excuse me, greater than or equal to 5, that is not a true statement. So that means 0, 0, and anything below this line does not work. And all of your solutions are above the line. Sometimes we need to rearrange in order to be able to graph. So we have to get the y value by itself. In order to do this, I'm going to get rid of my x's first because we need to get the x over on the other side. So my expression says negative 2y is less than negative 6 plus 4 because it was a positive 4 to start. Remember, when you are solving and you divide an inequality by a negative, so in this case, I am dividing by negative 2, we have to flip the inequality sign. So I'm going to now have y is greater than, negative and a negative make a positive, 6 divided by 2 is 3x, and then positive 4 divided by negative 2 is going to give me a negative 2. So I've rearranged so that my equation is in y equals mx plus b format, except for there's no more equal sign. So I'm going to go ahead and pull out my y-intercept now. So at 0, negative 2. And then my slope is at 3, 1. So up 3 and right 1. So I'm going to go 0, negative 2 to start. Up 1, 2, 3, and 1 to the right. Up 1, 2, 3, and 1 to the right. This time, because I do not have an equal sign included in my inequality, I am going to use a dashed line when I graph. So I have that dashed line to symbolize the fact that my line itself is not included in the solution. So now what I need to do is once again go back and plug in a test point. Again, I like to use 0, 0. You can pick any ordered pair on the graph, but I'm going to plug in 0, 0 and say 6 times 0 minus 2 times 0 is less than 4. When I do 6 times 0, I get 0. 2 times 0 is 0, is less than 4. 0 minus 0 gives me a statement that says 0 is less than 4. That is a true statement, so that means that the point 0, 0 is part of my answer. That is one of the possible solutions. So once again then, I'm going to go ahead and highlight the side that works. In this case, that's going to include my test point. So everything in this case that is going to be to the left, all of these points that are to the left, once again, you want to make sure you don't cross over that line. A little bit more difficult on the computer, should be a little easier to shade when you are using paper and pencil, but we want to shade in that whole side. So any single coordinate pair that would fall on this side of the line is a solution. Any coordinate pair that falls on the opposite side of the line is not. Go ahead and try this one on your own. Rearranging by subtracting 8x and dividing everything by 2, pulling out our y-intercept and our slope to graph our point. And then once again, I plugged in 0, 0. For my test point, I got a statement that did not work, so 0 is greater than 16. So that is not part of our solution, and we shade on the opposite side. Last example here. If you have a singular variable, we're still going to go about this the same way, but we have to graph our line a little bit differently. So you need to get your variable by itself. In this case, it's y. So I'm going to divide both sides by 4, giving me the statement that y is greater than or equal to 5. Remember, when you are on a coordinate plane and you are graphing with a single variable, you have to write the coordinates. So in this case, the only thing we know is that y is 5. So I'm going to graph the point 0, 5, and I'm going to graph another point at 1, 5, and if you wanted to do a third point, you could go at 2, 5. So anywhere where the y value is staying at 5 and we are changing the x's. So up 1, 2, 3, 4, 5, and then at 1, 5, and then at 2, 5. So we have our graph here. Because we have an equal sign included In our inequality, when I graph, I'm going to use a solid line. So this is going to be a straight horizontal line going all the way across the graph. Once again, you still have to plug in a test point. So I'm going to, once again, use 0. So 4 times 0 is greater than 20, giving me the statement 0 is greater than 20, which is false. That does not work. So that means 0, 0 is not included in my graph. So I'm going to shade the other side of the line, aka above the line. And all of my solutions up here are going to give me the correct answers to this inequality. Anything below the line would not. Go ahead and try this one on your own. In this case, we solve for x. We can write our points of 6, 0, 6, 1. You could go up to 6, 2, 6, 3, 6, 4. Either way, you're going to end up with a vertical line. It is dashed because there is no equal sign in our inequality. When I plug in 0, I find that 0 is less than 12. So my point 0, 0 is going to be included in my inequality answer. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.